Going to be doing our maximum design problems. So this means that we're going to be pulling back our ideas of quadratic formulas. So we talked about quadratics a little bit when we did the cones, and we said that you don't need to write this part down, but when we have a cone, when we slice it different ways, we get different shapes, right? So let's do like just a quick review, because this is what we just did for cross section. So Megan, if I cut off the top, what's that cross section going to be? Okay, good. So it'll give us a circle. And that was from chapter 7, right? And then if I cut off through the base, okay, what shape is that going to give me? What do you think?
A triangle.
Close. You're almost right. Ben? Okay, it can give us a hyperbola, and then what's the other one if we go at an angle? A parabola, right? So for this one here, so one of the things we didn't say or talk about very well was that when I slice off the corner here, so when I get, see if I can draw this, it's going to be a little bit weird. So there we go. Okay, so it looks kind of like a cave. When I go at an angle, that's going to give us the parabola. If I do a straight up, a vertical one, that one's going to be the hyperbola. Okay, and I think in the picture I had it where both were angled. But really, it's when it's vertical through the base that gives us the hyperbola. When it's at an angle, that gives us a parabola. So you don't have to write this down. This is just to kind of remind you. So these are the two shapes that we studied in chapter 7. And we didn't call them conics because we didn't know about cones yet. Okay, so these are conic sections because they can be they are the cross sections of a cone. So how is this related to what we're about ready to do? So we're about ready to work with parabolas again, okay? So we're looking at our 3D shapes and what are the different applications of them. One of them is we talk about cross sections, and then now we're going to be working with one of the particular cross sections, which is our parabola. Okay, so let's do a review here. Make sure we remember a couple of ideas. So for quadratics, we have this basic formula here. And then we worked with it in completing the square and then finding our vertex, right? So that's one of the things that we worked with. So for us, we're only working with maximum quadratic. So what that means is our A has to be negative. So there are applications for minimum as well, but we're not going to do that this year. You're going to work on that next year. So the only parabolas we're going to have are going to be for A being negative. So A will be less than 0. So Reagan, what does that look like for your quadratic? Is that the pointed up or pointed down? If this is negative, so it'll be pointed down. Okay. And then Josh Davis, is that, what is this dot called at the top here? Do you remember? Okay, good. You seemed hesitant.
Yeah.
Okay, you're right. It's a vertex, right? Or H or K. And then Jeffrey, do you remember what this dot right here was called in the middle? The focus. Okay, good. I'm not going to write it all the way out, but just to kind of jog our memory. And then Corinne, the line above, what was that? The directrix. Okay, good job. Okay, so for this question, or for what we're going to be working with, we're going to be working with maximums, okay? So when you look at this, Blake, where is the maximum on this parabola? It's the vertex. Okay, good. Okay, and then let's see here. Cooper, where's the minimum? It's kind of a trick question.
Infinite, because it's always going down.
Good. Okay, so it would be negative infinity, right, because it's always going down. But we also would just say there really is no minimum, because the minimum implies that there's a lowest value, and infinity is not a value. Okay, good job, though. So we can find our vertex by completing the square. And we're good at that. We've practiced that quite a bit. But there's another way to find our vertex, and that's what we're going to learn right now. So for us, we want to find values for h and k. So this is a formula that we can use. And if you don't like to use the formula, you can just complete the square. Okay, so I'm just showing you another way to find the vertex. So we can find the vertex by doing h equals, and then finding our value for b, which is what we're multiplying x by, and then divided by twice our stretch. So a is our stretch. So this is a formula to find vertex. And then to find our k value, we would just replace x back in to our equation. So I'm going to use f right here, meaning our function. So all we're doing is substituting okay, so these are, so it's really just one formula, the h equals negative b over 2a, because the other one is not a formula, it's just evaluating. Okay, so we'll do an example here just so we can kind of see how can we find our vertex. So our homework questions are going to be application problems, but before we do an application problem, I want to make sure we can at least do the math first, okay? So all we're going to do is just practice finding the vertex. So what we're always going to want to make sure we do is have it in the right order, because right now the x squared should not be the last thing, right? It should be the first thing. So we always want to put this in the right order. So we're going to do that first. So we're just going to reorder it. Okay, so then instead of 40x minus 2x squared, the x squared should go first, so that would be negative 2x squared. 40x is positive, so plus 40x. So all I've done is reorder it, and then now I want to use this formula here. So I want to find my vertex, so I'm going to use h equals negative b over 2a. Okay. All right, so then let's look back up here. So look to see, where do I look for a? A is what's multiplying the x squared. Where do I look for b? B is what's multiplying the x. Okay. All right, so Sam, which of these two numbers is my a value? So negative 2. And then what is b value? 40. Okay, there we go. Okay. So it's ax squared plus bx. So there's no c here, right? But do I even need to have a c value for these problems? Okay, it's okay if I do, but I don't need to know it. And then Joseph, what's the formula that we use?
The negative b over 2a.
And then that finds me the h for my vertex, right? So negative b. So what's going to go on the top of my fraction?
Negative 40.
And then in the denominator?
Negative 2. Oh wait, 2 times negative 2.
So if we look here, we're replacing b with 40. So instead of just being b on top, it'll be negative 40 over 2 times a, and my a value is negative 2. Okay. And so what is that going to give me?
Oh, that would be negative 4. Wait, what?
I mean, for the whole answer.
Oh, for the whole
Mhm.
It would be negative. It would just be 10.
Okay, good. Okay. So 2 times negative 2 is negative 4. The negatives will cancel, right? And then 40 divided by 4 is 10. Okay, so there's my h value. So then now for k, it says to substitute your value of h into the original problem. So substitute the value of h into the original problem. So that's what this notation means here, right? So this is like our y equals f of x. Okay, and now we have a number for x. Okay. So then, Eduardo, what am I going to do with the 10? Where do I put 10? Mm-hmm. And then how do I find that number? What do I have to do to find that number?
What number?
How do I figure out what that value is? So I know that h is 10. And what does h represent? Is that a value? So if I look at my vertex, is that a value for x or a value for y? It's a value for x. So we call it h because it's a special x value, right? It's the vertex x value. So then h is 10, so this is a value for x. So I want to know a number for my y value, corresponding y value, which is our k. So when it says to substitute the value of h into the original problem, so here's my original problem here. So the 10 that I got, is that for x or is that for y? For x. So then I'm going to do 40 times 10 minus 2 times 10 squared. Okay, so let's add to this just to make it make more sense. So it says substitute the value of h into the original problem for x. Does that make more sense now? No? Mm-mm. So then this is an x value that we just found. Okay. It's a special x value. It's my vertex, right? My vertex x value. All right, and then let's work this out. Is that 200? Okay. And so is my k an x value or a y value that I just found? It's my y value. Okay, so one of the things that can get a little bit confusing is the switch up of the variables. So when we do our homework and when we do the examples, we use different variables. Okay, not all of the variables are the same. So we don't use x and y for everything. We use t's, we use p's, q's, r's. We use all kinds of letters because we want them to be relevant to the question that we're working on. So one of the things that we have to kind of get used to is, although this is in terms of x and y, okay, is that we will have things that will be in terms of revenue and profit. We can have price point. We can have time. We can have height. We can talk about altitude. We can talk about perimeter and area. So we're going to use different letters all the time. So we have to kind of understand that when we talk about functions, it's always y is a function of x, that these letters don't have to correspond to what is going to happen over here. So we're going to have to kind of watch for that. Okay, so let's talk about the first style of problem that we're going to do. Okay, so the first problem that we're going to do is we're going to talk about what they call free-falling problems. So, but we're going to be doing something like this. Okay. So sometimes they'll call these motion problems, just in general, motion. So if we, and it could be a lot of things. It could be a stomp rocket. It could be a kid throwing a ball. It could be an archer, shooting a bow off into the, but all of them take on that general form, okay? So what the questions that we're going to have to ask or answer are, how high, like what is its maximum height? Like those are the kinds of questions we're going to have to know. So we're going to have to know what is the maximum height. Okay, we're going to have to know when did it get to the maximum height? And I'm just going to use the word it because it could be all kinds of things. And both of these questions are answered by finding the vertex of your parabola. Because if I go and find the ordered pair for here, then I know how long it took to get to the maximum height. That's my value for x. And then I know what that maximum height is, and that's my value for y. So which of these two is using the formula h equals negative b over 2a? Is that the what is the max height or when is the max height? It's the when, okay? So for this one, for the when, that's when we're going to be using the negative b over 2a formula. And then substituting it in is what's going to find us the what. Okay. All right? Okay, so let's do an example just so it can hopefully make sense here. Oops. Okay, so this is question number, kind of like it's our 8. Okay, so this is, I meant to say example 2. It's problem number 8 on our homework. I'm just going to kind of abbreviate it just so that we have to not have to write it all the way down. And there is a typo on this. I started out talking about an arrow, and then all of a sudden I switched to balls. So, okay, so it's not a ball being thrown into the air, it's an arrow being shot into the air. Okay, so this right here, this is our equation, okay? Okay, so I'm going to cover this up for a quick second. So we're going to be changing up our variables, so we're going to use the ones that are appropriate to the problem that we have here. So I'm going to be using negative b over 2a, right? And I need to look and pay attention to what the letters are that I'm trying to find. So I don't have any x values or any y values in here. So I don't want to have like x equals negative b over 2a or y equals negative b over 2a. I need to figure out what letters are what. So one of the clues is they tell you that they want to know how many seconds, and we have also questions about height. So what do you think the H stands for, and what do you think the T stands for? Okay, so let's figure that out. So Miles, what do you think the H stands for? And then the T? So our T is our time, and then H is our height. So what formula am I going to use in order to find out how many seconds it takes? Okay, so I want to know when, right? So when did it reach the maximum height? So that would be negative b over 2a. Okay. So I'm going to use the formula, and I'm going to use the appropriate, so I'm trying to find t, so use t equals negative b over 2a. So let's put the formula in the right order. Okay, so Dechia, what should come first? The 64t or the negative 16t squared?
Negative 16t squared.
And then what will be after that? Mm-hmm. And then Ari, which number is our a value?
Negative 16.
And so now, so see how I'm mixing up the letters? All of a sudden it now says t equals and not h equals, right? Because the t is answering the when question, okay? So this time, so this represents different letters. So we always need to pay attention to what value it's representing. And it's always going to represent whatever variable is over on this side here. Okay. All right, so then let's set up our equation. Okay, so Fernando, it's going to go in the numerator if I use this formula. And then you guys figure that out for me. Tell me what you get. What do you get? Negative 4. Wait, just he's not negative 4. Positive. So the double negative will cancel, be positive. And then did anybody else get 4 to check it? I'm guessing no, since there's okay. Megan, what did you get?
Negative 2.
Negative 2. Did anybody else get? Well, I feel like it shouldn't be negative. Just 2. So the negatives cancel.
Wait, if you know, it would be, if you do negative 16 times negative 16, that would be a positive.
Mm-hmm.
So it would be negative.
Well, if it's squared, you're thinking of if it's squared. Positive 2, right? Yeah. Okay. Yeah. It's just good old-fashioned arithmetic. So it takes 2 seconds, okay? And then for part B, oops. Okay, so for this one they're asking how high does the arrow go? So how high does the arrow go? So they want to know how high. So do they want to know the value for t or the value for h? If they want to know h. Okay, good. So Joseph, any ideas on how I'm going to figure out h?
Well, you would plug 2 back into the original.
Okay, good. So we're just going to substitute our answer for here back into the original equation. So we're going to take what we got here and we're going to substitute it back up into here. Uh-huh.
Why didn't you, okay, because we were saying how high does the ball go, right?
Yeah.
So if it reaches maximum height in 2 seconds, can't you just do 64 times 2 if it's going 64 feet per second?
The initial velocity, you mean?
Well, yeah. Well, because on on the paper it says that it's going 64 feet per second. So if it reached its maximum height in 2 seconds, can it be 64 times 2?
So the original says initial speed of 64 feet per second. So does that mean that for every 1 second, it's always going to go 64 feet? When you throw a ball up into the air, is it always at 64 feet per second, or does it slow down a little bit?
No.
It slows down. What's making the ball slow down? Gravity, right? So even though the initial velocity, that means the second it left the hand, or the whatever, it was 64 feet per second. But 1 second later, it's going to be slower. It's not going 64 anymore. But yes, you could if it wasn't slowing down. So if there was no gravity, right?
Yeah.
But then you could do that. But that would have been nice. Okay. So then I'm just going to replace t with 2. Uh-huh. Oh, it would be easier because then we don't have to deal with the negative. I don't have to, but it would definitely make it easier. So I'm going to do what Eduardo suggested. Did you hear what he said? He said use the original because then we don't have to deal with having that negative in front. Not that I have to. I could have done the way I was doing it, but it makes it to where we don't have to deal with paying attention to the negative or just subtracting. So if you already have it done, though, your answer will not change. So all I did was take the original problem, and I'm going to replace t with 2. And then you guys do that for me and tell me what you get. 16? Oh, 64? No, 64? 64? 64 what? Did I say? I think it was feet. Okay. All right, got it? Okay. We're going to try to squeeze in one more here. So this one is problem number 11 from the homework. Okay, so I'm just going to actually do this on the worksheet itself, okay? I want you guys to do the same, okay? So for question number 11, they're asking us to maximize again. So whenever they ask us to maximize, we need to use that formula, right? And then Wesley, what's that formula that we're using whenever they ask us to maximize? Okay, so negative b over 2a, right? So we got to know that. Okay, so now let's label what's our a, what's our b, okay? So negative 5, is that my A or my B? And so then B is 100. Okay. And what is that going to find me when I do that? Is that going to find me my value for R, which is revenue, or my value for P, which is price? What's that going to find? It's going to find me price. How do I know that? Because that's the side that I'm working with, right? So these are values for P, and P is price. I'm going kind of fast, but our bell is going to ring here in just a second. So I'm going to do my value for price. So negative B divided by 2A. You guys do that for me. So find what P equals. So Kindle, what's going to go in the numerator?
Negative 100.
And then what's going to go in the denominator?
2 times negative
And then did you work that out already? No.
That would be
10. And then I'm assuming this is in dollars. It doesn't say, but I'm guessing it's in dollars. I mean, I guess it could be in yen or pesos, but it's probably dollars. Widget sounds like an American-made product. In pound, it can be pounds. Okay. All right, and now how am I going to find maximum revenue? So how do I find the R now? Okay, so how am I going to do that, Cooper?
You take the P that you found and you plug it into the equation.
Okay, good. So the P that I found and plug it into the equation. Did you do that already? What did you get?
$500.
And we're guessing on the units here, but I'm assuming it's dollars. Did anybody else get 500 to check it? Yeah? Yeah. Okay. All right, and that's it. Okay, so that's the end of that. And then I didn't